Welcome back to the Animation Programming Guide. In this video we're going to demonstrate collision and hit detection in the DOM. The DOM is the normal web development environment. We already made collision and hit detection tutorials for the HTML5 canvas in my Canvas Bootcamp playlist, which you can find on my channel anytime you want. That's already there. And that series also deals with a lot of animation concepts for the canvas. But in this lesson we're working in the DOM. The example that I wrote up today stems off of the code that we left off with in the last video in this playlist, number 4. And you can get today's lesson code by following the link that I put in this video's description text under the video. Now, the code that we left off with in video number 4 gave us something that allowed the user to control an object's animation on the screen by giving them control buttons. And you can give them controls in any way that you like, but the basic effect was allowing the user to control the movement of an object on the screen. And that can be a player character or whatever kind of object that you want. It can also be just normal DOM elements. You can allow people to move a form field, a button, an image, whatever you want. So what we'll do now is add another object to the screen, and then as this object is being moved by the user, if it happens to collide with that other object, then we want to have something happen in our program, a collision detection. So we're going to go down into the code, and right here where we have the player div, we're going to add another one that has an ID of thing1. Then we're going to go up into our CSS, and we'll put the style rule for thing1, so it will have all of these properties. And if we look at our program now, we'll see that we have thing1 sitting right here, which is the little blue box. And remember, it can be anything that you want. It doesn't have to be a little blue box, and it doesn't even have to be a div. It can be any type of element that you want. Now right now, if I was to go and collide into that or move into it with the other object, nothing happens. So now we're going to go down into the script, and here where we're initializing some variables that our program will use, we're just going to add some more variables to initialize. And this variable P represents the player object. This variable T represents thing1. Then we're going to represent player width, player height, player X position, player Y position. X position is where it is on the horizontal plane on the screen. The Y position, or where it is on the vertical plane or the vertical axis on the screen. And the same for thing1. Its width, its height, its X position, and its Y position. And here we're going to go down into our function docReady, and this function is where you get everything ready in the program after the document is fully loaded. So this is where you can set a lot of things up before the program runs. So I'm just going to take this line and copy it, the one for the player, and I'm going to put T representing thing1, which was the variable that represents thing1. And then we'll just put thing1's ID here. That way we have an object reference ready for thing1. It's represented by variable T. And in this docReady function, we're also going to run a function or start up a function called detect collisions. So it's always going to be detecting collisions on the screen right when the program starts up. And let's go ahead and put that function detect collisions into place now. I'm just going to put it right here where the other functions are written. I'll put it right above at the top. And here we have this function will be set to repeat very fast. Now the way this detect collisions function is set to repeat very fast is the method that we discussed in video number 4, which is the request animation frame method. So when you run request animation frame, it's going to be something like 60 frames per second. It makes this detect collisions function run over and over again. 60 frames per second. Approximately 60 frames per second. Now I'm going to take you through all of this code line by line, explaining every bit of it. But essentially, our hit detection logic is sitting right here in this if condition. So it's basically one line of code that handles the logic. So the first thing we do inside of detect collisions is we access the current location and dimension of both objects. So we have to know where they are on the screen and how big they are. So those are the variables that we're going to get. We're going to get the player's width, the player's height, the player's X position, and the player's Y position. Then we're going to get thing1's width, height, X, and Y positions using all of these properties in JavaScript: offset width, offset height, offset left, and offset top. That lets you know where it is on the screen and how big it is. Then once you know how big the object is, or both objects are, and where they are on the screen, then you can set up some logic in an if condition. And if they happen to be intersecting or collide, then you can run any code that you want to make anything happen in the program. So first, before I explain this code right here to you, which is not overly complex, but it's the most complex thing in the script that we have here, let's take a look at what happens in the browser. So if I move right, I collided with the object, and the object went away. So the player object ate thing1, or collided with it and made it go away, and that code was document.body.removeChild t. So you're removing from the screen thing1. And you can also have code in here that gives a point to the player object if it happens to collide with thing1, or any kind of functionality that you need to occur. And I'm also going to show you how to run over an array of objects, so there wouldn't be just one thing. There could be many things on the screen that the player will run into or collide with, and you can make whatever you want happen. So we'll do that in just a second, but first let's explain this code real quick right here. And what we're doing with this line of code is we're checking to see if thing1 has intersected with thing2. Actually, let's call this player. Check to see if player has intersected with thing1 in any direction. So if the player object happens to be coming from the top and collides with thing1, it will still have a collision detection that works just like it does here. Or if it's coming from the left instead of going right, for instance, if I was to say left 300 here for player, and we check that out, and we go left, right at the moment of collision, you can see it takes it away. So let's just put this back on 20. And now let's explain this code real quick. Now all this is doing is taking the objects, both objects' size and where they are in the screen, and constantly checking to see if there's an intersection, if they intersect or collide. And it's just knowing those values and a little bit of math. You can see we're using plus here to add the player's X position to the player's width. So we're taking player's X position plus the player width, and we're checking to see if that value is greater than thing1's X position. Then we use the AND operator to make sure that we're checking to see if the player's X position is less than thing1's X position plus thing1's width. Then we use another AND operator to accommodate for the vertical axis to see if player Y position on the screen is vertical axis plus its height is greater than thing1's Y position on the screen. And we're also checking to see if the player's Y position on the screen, its location in the vertical axis, is less than thing1's Y position plus its height. Now there are a lot of different ways that you can set up this detect collisions function. For instance, this if condition could be inside of its own external function, and you just feed variables into it and objects. That way it runs independently of the detect collisions functions, but it would be pretty much the same as being inside of the detect collisions function, which all the detect collisions function is doing is running 60 frames per second approximately. So you just basically want to make this code run at a high enough frame rate to where you're always detecting collisions in the screen for any amount of objects that you desire. And you can also have math involved, more complex math involved, to create any type of shape that you want or bounds area for these objects. If you don't want to use their true size and shape, you can make this formula a little bit more complex. For instance, if you wanted to detect collision only in a small area inside of player 1 and not its whole size, or if you wanted a different kind of shape detecting on the collision and not its actual size, you would just have to add more math within this line to make any imaginary type of bounds that you want in relation to where player 1 is. For instance, you can have it detect collisions if you put math in to make the box imaginarily bigger. You just have to add more math, like 20 more pixels, and then it will detect collision before it even hits. You see what I'm saying? So that math could be added by you according to your personal needs, or according to your specific needs. Now here's another file's code that I'm going to give you that you can play around with. And what this one's doing is it's changing t from being just one thing to 3 things. So let's take a look at what that renders. And actually we'll look at that in Firefox. And we'll open up the developer panel, the web console. And what we'll do is start moving. And then you see in the web console that it logged collision detected with thing 1. And if we keep moving across the screen, collision detected with thing 2, collision detected with thing 3. And even if you start, for instance, let's put the player at a left position of 400 pixels. Okay, at 400 pixels, it's already detected the collision of thing 1 when the program starts up. As we move left, detected with thing 2, detected with thing 1. Now the only difference between this example and the first example is that thing 1 has now become an array. So we use the get elements by class name over things. And you can see that each of the things that we want to detect collision for has a class of things, but they each have an individual unique ID as well. But they're all grouped together using the class things. So here T is now an array. Instead of being just a single object, it's a group of objects that all have the class of things. So what we can do is in our detect collisions function, the only difference in this function now is that we're iterating over the length of the array using a for loop. So for each of the objects in that array, this for loop will run one time for each. And you just set up your variables to represent each one of the objects within that array. So you know its specific individual width, height, x position, and y position that's different from the other things. And this code is exactly the same. Nothing has changed there. And when we're removing child, we're just referencing the thing in its position in the array. So each time this for loop runs, this I variable is going to start at 0. So that's the first object in the array. And then it's going to I++. So it'll be the next time it runs, this I will be a 1. Then if it runs the third time, this I will be a 2. And that's how you target each one of the objects in the array independently or in succession. So the fundamental difference is that you're now putting a for loop in here and you're using an array or a group of objects that you want to detect collision for, because T now represents an array of objects instead of just one thing. It represents 3 things, and it could be 50 things if you wanted. So that's about it. I'll have both of the code examples where you can find them, and I'll have a link to that code in the description area under the video. And you might want to set your program up to do different things. For instance, giving the player a point each time it runs into one of those objects, or you can kill the player. You can make these little saw blades, little images of saw blades, and then as the user's running along, if he happens to hit one of the saw blades, you can make the player die. You can do whatever you want in the program. It's up to you. Or it doesn't even have to be a game. This can just be a box with words in it, or a form field, or any type of web element and as it runs into something else, maybe you want to make that something else, that other thing, bounce away or move away, or an animation start on that other item that it runs into. You don't have to take it away from the screen or off of the screen. You can do whatever you want. Now, none of this CSS has to be in the document. You can externalize that. None of this code has to be directly in the document. You can externalize all of that. This if condition can be in its own separate function that runs by being given arguments and parameters. But I just set it up this way so it's not overly complex and you can really grasp what's going on. So don't focus so much about how I have my code set up. You don't have to have your CSS in the document. You don't have to have your JavaScript directly in the document. This code down here, these on mouse down and on mouse up events could be set up within your docReady function using add event listener in your docReady function to give event listeners of mouse down and mouse up to these button elements. And it wouldn't take much work at all to make these things get this out of the HTML, for instance. It wouldn't take much work to externalize this, all of this CSS and all of this JavaScript. It's very simple to do. Okay, I hope this lesson in collision detection for the DOM was helpful to you and that you enjoyed it. And we'll be getting into a lot more cool stuff as the series progresses.